Next, problem 2 of simple band brake, example 6.33. A simple band brake operates on a drum 600 mm diameter and running at 200 rpm while absorbing 15 kW of power. Coefficient of friction is 0.25. The brake band has a contact of 270 degrees and one end is connected to the fixed pin, another end is connected to the brake arm at 125 mm from the fixed pin. The straight brake arm is 750 mm long and is placed perpendicular to the diameter and backsets the angle of contact. Determine maximum effort required to stop the rotation of drum and width of 2.5 thick steel band. If the maximum, you have to find the width of 2.5 thick steel band if the maximum tensile stress is not exceed 56 MPa and design the lever. So here the diameter is 600 mm given, so half of its radius is 300 mm, power is 15 kW and iron RPM is 200 RPM, mu is 0.25, theta is 270 degrees. H, this H is thickness of the band that is 2.5, sigma D is 56. Then I have to find next. So this is a given. So this is a figure. As you can see, the theta is 270 degrees, angle of overlap. One end is connected to the fixed fulcrum, other end is connected to the brake lever. This is the brake lever, is connected here, and distance between this is 125 and the brake lever is 750 mm. This is given. Now using the first procedure, so find the torque transmitted. So torque transmitted formula, mt is 9550 1000 n by n. N is power, small n is speed. So substitute the values of 9550 1000 n by n. 9550 1000 n is 15 kW upon speed 200 rpm. You get 716250 Newton mm. Therefore, next second procedure to find the actuating force EF. Actuating force of mt is F theta into R. Mt is known, R is known, so therefore we find F theta. So mt equals to F into R 7962. So Ft is equals to 2387.5 newtons. Now by data and book, using the form by data and book, so we get this formula from table 19.1, table number 19.1. So figure page number 19.21. So these two formulas for clockwise and counterclockwise, if you have to use both formulas and find both F and choose the maximum F. So this we get in table 19.1. So we get it by 1, we get it as 176 newtons. So by other formula we get it as 574.9 newtons. So maximum is 574.5 newtons. Next, third procedure is to find width of the steel band. So now width, you have to find width W of steel band. So H is so the formula for width of steel band, W equals to T1 upon H sigma D. So therefore, to find T1, you have to use the formula mt equals to T1 minus T2 into R. So mt equals to T1 minus T2 into R. So mt is known. So T1 minus T2 is unknown, into R is 300. Therefore T1 minus T2 is this much. So also you have to use the formula T1 by T2 e to the power mu theta. So we have to use these two formulas to find T1 T2. So T1 by T2 e to the power mu theta. Mu is 0.25, theta is 270 into pi by 180. You have to convert. So this whole into calci, we can find it as 3.2482. So the T1 by T2 is this much, or T1 equals to 3.2482. Substitute this in this equation. So we get therefore T2 has this much and T1 has this much. So substitute the values of T1 in the equation. T1, H is given, that is 2.5, and sigma D, that is lower stress in the band, is 56. So we get W as 24.69. But this is a normal band of the width. But if it is jointed by rivet, we use 4 rivets of 8 mm size in 2 rows. So therefore the width will be, after punching the rivets, the new width will be W equals to 25 into 2 into diameter of the rivet hole. 25 is the found width, 2 into 9, 2 in 2 rows into diameter rivet hole. A rivet hole should be 9 mm if the rivet is 8 mm. So therefore it's 9 mm but 43, so we get it 45, rounded to 45 mm. That's width of the band. Now check for stresses. So check for stresses, we can use directly the crushing stress. So T1, this has to be less than sigma d, allowable stress of the band. So T1 IDH, so 344.9 upon I is number of rivets, that is 4, D is the diameter of the rivet 8, H is thickness of the band, that is 2.5. so this is 43.12, which is less than the allowable stress in the band, that is 56. So hence it is safe. Next, design of lever. So design of lever, since allowable stress in the lever is not given, we have to assume C for the steel. So we'll assume C for the steel and Fs of 3. So 6 for the steel, sigma y is 328.6 MPa. So allowable stress in the steel brake lever, sigma b equals to sigma y upon Fs, that is 109.53. So we'll use this. So the sigma b is 109.53. Now maximum bending moment F max into A. F max is maximum force which found earlier into A. We get this much Newton mm. Also I is B H1 cube by 12. So we'll assume the thickness has 3 times the width. We'll assume this, and C is H1 by 2. We know this. So I is B1 3B1 cube by 12, that is 27 by 12, B1 4. C is H1 by 2 or 3B1 by 2, that is 1.5 B1. So therefore substitute values in all these values in bending equation, M by I into sigma by C. So we get as 43115, 27 by 12 B1 4 upon that is sigma D, that is, and C is 1.5 B1. So we get B1 as this much. So therefore B1 will round it to 14. The thickness is 3 times, that is 42 mm. So this was about the problem 2 of band brake.